What is up? Welcome back again. We are working through the rest of Module 4, which is our Solving Quadratics module. So we're going to go through the other techniques for solving besides factoring, which are completing the square, graphing, which we've done already. So we'll kind of review that. And then this quadratic formula. All right. So starting today, we're going to take a look at how to do completing the square. Okay. Before we talk about how to do completing the square, let's talk about what a perfect square is and how do we figure out, if given the perfect square, what the standard form is, and if you know the standard form, how do you figure out the perfect square? So understanding this concept is key to doing completing the square. So let's look at the first example. So the factored form is x plus 1 squared. So what this actually means is x plus 1, right, times x plus 1. And then when we distribute, we go ahead and multiply the x's through and then the 1 through. So we're going to get x squared. X times 1 is positive 1x. 1 times x is positive 1x. And 1 times 1 is positive 1. So that turns into x squared plus 2x plus 1. All right. And the same thing with the second one. So we have x plus 2. And then we have x plus 2. And so we distribute, once again, we're going to do the x's through. So x times x is x squared. X times 2 is 2x. Now we're going to distribute the x from here, or sorry, the 2. So 2 times x is another 2x. And then 2 times 2 is 4. So I get x squared plus 4x plus 4. All right. And if we do the next one, which is x plus 3, and after this one, we'll start looking for the pattern here, okay? Maybe you already recognized it, but we'll start looking for it. So we're going to do the first term, so x through. So x times x is x squared. X times 3 is 3x. Then the 3 times x is another 3x. And then 3 times 3 is 9. And so I get x squared plus 6x plus 9. And so hopefully you're catching on that the first term, right, is just whatever the first number in here is squared, okay? The last term, right, the 1 or the 4, right, is just what the last term in here is squared, okay? So the first term squared goes in the front, the last term squared goes in the back, all right? So that's going to be the key here. And then the middle term is actually adding these two things together, or actually multiplying them together and adding, and then doubling. So it's like 2 times x times 3, right? 2 times 2 times x is 4x. So this is really 2 times 1 times x, gives you the middle term. This is 2 times x, gives you that middle term. This is 2 times 3 times x, gives them the next middle term. So if I'm looking at x plus 4 and x plus 4, okay, the first term is x, so this is going to be x squared. The last term is 4, so that's going to be plus 16. And then it's 2 times x times 4, which is 2 times 4 is 8, so that's 8x in the middle. So x squared plus 8x plus 16. So what if we change this? What if we made this 2x plus 5 squared? How does that kind of change stuff, right? Let's see how this works with 2x plus 5. So the first term is 2x, right? So 2x squared is 2x squared. 2x quantity squared, right, is 4x squared. Okay. The 5 squared is the last term, so that's plus 25. And then we're going to do 2 times 2, right, x times 5. So 2 times 2 is 4, times 5 is 20. So this is plus 20x plus 25. So if we actually do the distributing, right, 2x plus 5 times 2x plus 5. Now, for our circumstances, we're only going to have x's in the front here. We're not going to have a number in front. If we do, I'll show you how to handle that. So we distribute the 2 through, right? So we get 4x squared. Let's clean that up a little bit. 4x squared. Okay. 2 times x times 5 is plus 10x. The 5 times 2x is another 10x, and 5 times 5 is 25. So these two 10x's here give us 20x, right? 4x squared, and that's how it works. So if we did x squared plus 20, right, or x plus 20 squared, first term squared is x squared, the last term squared is 400. 20 times 20 is 400, okay? And then 2 times x times 20 is 40x, so plus 40x. Now, what happens if I made it negative? So I did x minus 6 squared negative. Well, the same thing's going to kind of happen. The first term squared is x squared. Now, negative 6 squared is actually positive 36. Remember, you're squaring, you're going to get a positive number. And then 2 times x times negative 6 is going to give me a negative answer here, and that's negative 12x. So it just changes the sign in the middle if it's a negative. That's all that happens here. All right? So that's how you multiply. So now, if we kind of work backwards, we want to say, what if I gave you the standard form, right? What's the factored form going to be for this? And it should equal something squared, okay? So if you think about our parentheses here, I know it to be a perfect square, right, perfect squares, that the two numbers that I put on the sides here have to be the same in order for this to be a perfect square, okay? So the top number, remember, is what they multiply to. That's A, C on the top, and then B on the bottom. So this is 36 on the top and 12 on the bottom. So what two numbers multiply to give me, and just cleaning this up a little bit, multiply to give me 36 and add to give me 12. And hopefully you're thinking to yourself, well, that's just 6 and 6, which is great. So that means it's x plus 6 times x plus 6, okay, which is x plus 6 squared. Easy enough, right? So if it's minus 12x, right, positive 36 minus 12, that means it has to be two negative numbers here, and negative 6 and negative 6 works this time. So this becomes x minus 6, and x minus 6 is my two factors, which you can rewrite as x minus 6 squared. There's two of those things. So if we're given 120, right, just like the next one, okay, so multiply to 100, add to give you 20. Add the 20 part is pretty easy, right? We know that's got to be the same number, so it's got to be 10 and 10. It could be like 18 and 2, but that's not going to multiply to give me 100. It's got to be two of the same numbers to be a perfect square. Okay, so if I did 18 and 2, right, these numbers aren't the same, so this isn't a perfect square. Okay, so I know it's got to be x plus something and x plus something where the somethings are the same. So it's x plus 10 and x plus 10, which we can write as x plus 10 squared. Now this is pretty easy, except now when I start getting into harder ones, what happens if there's a 3 here? Or something not nice, like this one doesn't have a number that multiplies to give me. So how do we kind of handle this situation? What we really want to do is go back and look at this number that we got here, this number 6, right? How did we actually use this to our advantage here? Okay, how do we get this number 6? Seriously. Okay, it's not doing things I wanted to. How do we get this number 6 here, right? From these two numbers, 12 and 36. How do we get negative 6 from these two numbers? How do we get 10 from these two numbers, right? And so what we notice is, hopefully you notice, is that this number 6, right, comes from the 12 because it's really 12 divided by 2, right? It's 12 divided by 2. That's what equals 6, okay? And what I need to do to get this to turn into 6 to turn into 36 is actually square it. So 12 divided by 2 is 6, and 6 squared is 36, okay? So the same thing happens here. Negative 12 divided by 2 in the second example is equal to negative 6, and then negative 6 quantity squared is also 36. And so the same thing happens here, right? 10 is half of 20, okay? And then 10 squared is 100. So I take 20 and I divide it by 2, and that equals 10, and then I do 10 squared, which is 100, okay? And this will always work. And so what we want to do is we want to come up with like maybe a formula for this, right? And so what we would say is if we do standard form again, which is ax squared plus bx plus c, the formula that we would use to do this is to take this number, which is the b term, right? We want to do b over 2, which is 6, and then we actually just want to square it, okay? So if we go back up and let's say we look at this number right here, okay? And I want to know what this factors into. All I'm going to do is take the b term, this term right here. I'm going to divide it by 2 and I'm going to square it. So 40 divided by 2 squared is equal to 20 squared, which is 400. So this tells me that the number on the end has to be 400. And it also tells me that this number that's inside the parentheses is what is going to go into the factored form here. So it's x and then plus 20, okay? And that means I have a 400 on the end. So we can use this to help us figure out what the perfect square is when the number's not nice, when we have something like negative 3x here, okay? So I'm going to use my formula, okay? So if I have x squared minus 3x minus 9 over 4, the b term is the 3, okay? So b over 2 squared is 3 over 2 squared, okay? And it's negative, so it's negative 3 over 2 squared. And then if I do negative 3 over 2 squared, that's 1.5 squared, okay? Which is actually 9 over 4, by the way. You square the 3, square the 2. This is 9 over 4, all right? It's 2.25. So that's what that becomes, okay? So hopefully, so far so good. And this should be plus, by the way. All right, so I now know that this number is the perfect square because that's what this equals. And I also know that in my parentheses, okay, because it starts with x here, it's going to be x, and then I'm going to look at the number that I get in the parentheses before I square it, the b over 2, that's what goes right here. So it's x, okay, minus 3 over 2 squared. All right, that's it. That's it. So if we look at the next one, x squared minus 100 plus 2500. I'm going to do negative, minus 100x, negative 100 divided by 2 squared is negative 50 squared, which is 2,500. So that's how I know this is a perfect square, because it's got that 2,500 that matches. So in the parentheses, I'm going to put x, because that's what it starts with, and then I'm going to look at what do I get before I squared it, and it's minus 50 squared. Okay, so let's look at the last one. If I look at x squared plus 8x plus 3, the b term is 8, okay? I'm going to do 8 over 2 squared, which is, ready for it? 4 squared, which turns into 16. So this is not a perfect square, but I can write it as a perfect square, okay? If I change it to 16, and then I have to have it equal 13. So it's going to be, I have to have this equal 3. So it's x squared plus 8x plus 16, but I somehow have to get this 16 to actually equal 3, because that's what's here. And so what I have to do is do a minus 13 on the end. So now if I write 8x squared plus 8x plus 16, the minus 13 will make it become 3. So this becomes x, right here, plus 4 quantity squared minus 13. That's what this is written as a perfect square. Seems a little bit weird. When we start getting into the quadratics part of it, you'll kind of see how this comes from, okay? And this is called the vertex form, which we've seen before. All right, so all I'm going to do is do some more practice today. All we're doing today is doing practice. So let's go down to exercises. Let's take a look at number 1. We want to write each expression by completing the square. So the first thing we're going to do is we're going to kind of ignore this number on the end. We're just going to focus on the first 2 terms, okay? So if it's a squared minus 4a, okay, I want to complete the square here. So the b term is negative 4. So if I do b over 2, I'm just going to rewrite that real quick. B over 2 squared equals negative 4 over 2 squared. Now I'm going to write it out one more time. That's negative 2 squared, which is 4. Okay? I want to see this because this is what's going to go in my parentheses. This is what's going to be my factored form. So it's going to be a squared minus 4a, and I want to put a plus 4 in the end, okay? But I have to have this equal to 15. So what plus 4 equals 15? 11, right? So I have to add an 11 here so that these two terms add up to the one on the end. So this equation is still plus 15. It's just written differently, okay? Now I'm going to take my perfect square part, which is right here, and I'm going to rewrite it using the minus 2. So it's going to be a minus 2 quantity squared and then plus 11. That 11's got to stay in the end. Okay, this is how it's written in completing the square form. All right, here we go. We're going to do it again. So let's go to the next term. Remember, we're going to ignore the negative 15 for now. We're going to n squared minus 2. I'll tell you what, let's do a quick aside over here. And let's say that I had this term, x squared minus 7x. And I want to add something on that's going to complete the square. How do we figure out what to add on to this? Okay, so we're going to take the b term, which is the negative 7. We're going to do negative 7 over 2 squared, which is negative 3.5 squared. And if I square 3.5, okay, I end up with 12.25. So this is going to become x squared minus 7x plus 12.25, and this is now a perfect square, okay? And I can write it in factored form as x, and here we go, right here, minus 3.5 squared. If you actually multiply it out, you'll get that, okay? That's it. That's it, okay? That's how you're getting the factored form. So let's go back to number 2. So I'm going to ignore the 15. I'm only going to do the, what do I have to add on to negative 2 to make a perfect square? So I'm going to go off to the side. B is equal to negative 2. Okay, so we're going to do b over 2 squared, which is equal to negative 2 over 2 squared. So we're going to simplify it. That's negative 1 squared, which is equal to 1. So I have to add a 1 on here. Okay, so n squared minus 2n minus 1. Now I still want it to equal negative 15, so I'm going to have to put a negative 14 down, so this becomes negative 15 if I combine them together. And now I'm going to write my factored form here. So this is n, go back to your parentheses over here, minus 1 squared minus 14. Okay, try the next one, see if you can do the next one. So pause it, try it. Okay, and here we go, we're going to do it together. You guys ready? Here we go. Okay, so same thing, completing the square, so we're ignoring the negative 40. So it's going to be 20 over 2 squared, which is equal to 10 squared, which is equal to 100. So I want to put a plus 100 on the end. So this needs to be c squared plus 20c plus 100. This is my factor, this is my standard form, but I need it to equal negative 40. So I need to put a minus 140 on the end so that these two things plus 100 and minus 140 will give me negative 40. Now I can rewrite this as c, go back to what did you get before you squared it, plus 10 squared, and then minus 140. All right. We're not going to do number 4, so we'll skip to the next page. All right. We'll try a couple more of these, and then we'll stop for today. All right. Tomorrow we're going to do some more completing the square and actually solving your quadratic equations. We'll see how this works. Okay, which we'll get there. So let's take a look at, we'll ignore number 5. We're going to go, well, we'll do an odd one. Let's do 5 and 6. These two, I don't do anything crazy. Yeah, we're just going to do 5 and 6 because the other numbers aren't very nice. All right, so same thing. So the b term is -3. So we're going to do -3. Just going to get rid of that first one. -3 over 2 squared, which is -1.5 squared. And when I multiply that together, that becomes 2.25. Okay, so we're going to go y squared minus 3y, and then that equals, so plus 2.25. Remember, I have to get it to equal 10. So what do I have to add to 2.25 to get 10? So 7.75, right? That'll give me 9, that'll give me 10. Okay, so here comes my factored form. So it's y minus, remember, go to your parentheses here, 1.5 quantity squared, and then plus 7.75. So just trust the b over 2 formula, okay? So b over 2 squared, whatever the b over 2 is, before you square it, that's what goes into the parentheses, okay? So number 6, same thing. All right, the b term is 7. So 7 over 2 squared is 3.5 squared. And I'm going to need a calculator for this one. 3.5 squared is 12.25. We just did that one on the other question. What you guys tell me that? Okay, so now we're going to rewrite this. So k squared plus 7k plus 12.25. That's our perfect square. We need to get this to equal 6, though. So we have to subtract 6.25. So that 12.25 minus 6.25 equals 6. All right. Now we're going to do our factored form, which we looked before we square it. We did 3.5. So it's k plus 3.5 squared minus 6.25. All right. Now, there are some problem set questions on the next page, okay? I'm going to not do these, but you can if you want to, all right? The only one I would probably say we should know how to do is probably 1 and 2, because I would not want to do these odd numbers and decimals, okay? So if you looked at the first one, right, 12 over 2 squared is 6 over 6 squared, which is 36. So we're going to rewrite this as, right, q squared plus 12q plus 36. That's our factored form. We have to equal 32, so we're going to subtract 4, so it equals 32. And then this q plus, remember, go back over here, 6 squared minus 4. Okay? And the same thing's going to happen with number 2. So -4 over 2 squared is -2 squared, which is 4. Okay, so we're going to rewrite this as m squared minus 4m, and then plus 4. We want it to equal -5, so let's put a -9 on it. So now that equals -5. And then our factored form is going to be m, right there, minus 2 squared minus 9. Okay, that's it. So I'm going to throw on the play pause it, keep watching, finish up the next couple questions, probably just 2 questions today on completing the square, and we'll go from there. All right, guys, have a great day.